I would now like to look at an example of solving trig equations where you have to use your calculator. You may want to pause this video at points so that you can take notes. First of all, I want to emphasize that you still have to solve the equation first for the trig function, and then you still need to determine which quadrants the answers must be in, and to do this you need to make sure you draw pictures. And so you still start these equations off the same way that you would start off a regular trig equation. If the sides of the triangle don't create a known special triangle, then this is when you must use your calculator and the inverse functions to be able to solve. Okay, be careful. Like I've mentioned earlier, using your calculator, first of all, the calculator may not give you the answers in the correct quadrants. It might not give you the right answer, and it might not give you all the answers. Okay, your calculator is a tool, and you need to decide how to use it. Think of the answers that are created on your calculator as, number one, a tool that will allow you to find what I'm going to call reference angles that will help you determine your solutions. Also, be sure that your calculator is in the appropriate mode. In other words, if I'm asking you to solve between 0 and 2 pi or something along those lines, you know that those answers are radians, so make sure you're in radian mode, or make sure you're in degree mode if the problem asks you to solve between 0 and 360 degrees. Okay, there's a couple of things that's helpful to know. For radians, just on your calculator you can estimate how much is, let's say, pi over 2. I've given you here a chart. Pi over 2, you know, is 90 degrees. Its estimate as far as a decimal is about 1.57. Pi, of course, is 3.14. 3 pi over 2 is 4.71, and then 2 pi is about 6.28. It's useful to know this. That way when you're getting decimal answers that are radians, you know which quadrant those decimal answers are falling in. For degrees, you pretty much already know this, but know where 0, 90, 180, 270, and 360 are located, so that if you are in degree mode, then you know which quadrant the calculator's giving you an answer in. So let's look at an example. Here I've said I want to solve cosine of theta minus 0.2 equals 0 on the interval from 0 to 2 pi. Okay, first of all, this tells me that if I am going to use my calculator, I need to make sure that I'm in radian mode. I already know that I'm going to have to use the calculator on this particular problem because of the decimal. This decimal, when I solve, is obviously not going to give me a special triangle. All right, first of all, let's solve our trig equation for the cosine function. So I'll add over 0.2 to both sides. I'll have cosine of theta equals 0.2. Notice also that my angle is a single angle. It's just theta, so I don't have to worry about, is it a half angle or a triple angle or something along those lines. Now, from here, this is what I want you to do, okay? That particular value, if you'd like to, you could put it over 1 to make things a little bit easier. Cosine, we know, is defined as x over r. And then here is what you must do before you go to your calculator. Just like before, we know that r is always positive. In this case, x is positive. So we're going to write out to the side, x is positive in quadrants 1 and quadrants 4. So you need to know, as the student, which quadrant am I looking for these angles in before you ever go to your calculator. And so what I want you to do from there is I want you to draw a picture and say, okay, so I know I have a triangle in the first quadrant, and I know I have a triangle in the fourth quadrant. And so I'm looking for theta 1 in here, and I'm looking for theta 2 rotated around to this side. Okay, now this is the point where you go to your calculator to determine your answers. For this particular kind of problem, me saying that cosine of theta equals 0.2, if I'd like to solve for my theta value, then what I can actually do is I can take the inverse cosine of both sides. Okay, what happens on the left-hand side is I'm taking the inverse of cosine, so in actuality you can kind of say The cosine inverse cancels with the cosine, and that leaves you with just theta, which is what you're trying to find. And then on your calculator, you're going to perform cosine inverse of 0.2. All right, once again, I'm going to let you do this on your calculator. I'm just going to tell you what numbers you should be getting here. Cosine inverse, do on your calculator. Make sure that the calculator is in radian mode. If you type that into your calculator, then you should get that theta is equal to 1.3694384006. On these problems, put as many decimal places as your calculator uses. Okay, these are estimates, so we want to use as many decimal places as we possibly can. Now, think about before, when I drew a chart here, we said obviously we got 0 radians, and then pi over 2 was approximately 1.57 radians, and so we can see that this particular angle is in quadrant 1. Now here's our situation. This particular problem, when we use our calculator and we perform the inverse cosine on 0.2, the answer that it gave me is actually one of my correct answers. Okay, now the problem is I have an answer in quadrant 1 and I also have an answer in quadrant 4 from what we've drawn up above. So how do I figure out the answer in quadrant 4? Well, basically use reference angles. So in other words, the angle that we just got was this one up. So theta 1, this is the 1.369. And we also need the one that's around here. Okay, but we still know that the reference angle in here, I'm going to call this the reference angle, is 1.369 and so on. And so what we can do to figure out that second answer is we can go and we can basically take 2 pi and subtract the value that we just got, 1.369438406. Type that in your calculator and we'll end up with theta 2 is 4.913746901. Okay, so there are our two answers. I'll kind of wrap this up. So on 0 to 2 pi, my solutions are theta 1 equals 1.369438406 and theta 2 is 4.913746901. And there are our final answers. Okay, we see for sure that theta 1 is in quadrant 1, and we also know that theta 2 is in quadrant 4 by looking at what we'd said before. 2 pi is approximately 6.28, and then 3 pi over 2 was approximately 4.71, and we see that the 4.91 and so forth lies in between 4.71 and 6.28, so we've got it in the right quadrant. This concludes this lesson on solving trig equations using our calculator.